Oh, there we go.
Yes.
All right, let me just see if this is gonna work this time. Okay, that does work. Okay. All right, so some norms for the talk. Gosh, so weird. This is showing me something different. Okay. This what happens. Okay. Be present as you can. We all have lots of competing things going on where it's impressive that you're here during the summer in this space, in the virtual space. I appreciate that. Remote participants, please do feel free to turn on your camera if you'd like to, especially during the activity and when we're interacting. In-person participants, of course, remember to silence your devices, and I encourage you to close your devices or your windows, because like if you're like me, you get totally distracted and things are within eyesight. Take care of yourself, it's totally fine. I'm not gonna take it personally if you get up and leave, or need to use that, or need something to drink, or just need to stretch your back. Be mindful of the space that you're in and be courageous to take up space. I'll just point out that last night, the people who asked questions first were men. Nothing wrong with that, but that's important for everybody to notice, right? So we want to make sure that the women in the room are being courageous to take up space and to share their perspectives as well. Please ask questions when they are relevant. You don't need to wait till the end to raise your hand, come up to the X, or just unmute and put a question in the chat. Often, if I wait to the end, I often forget the very pertinent question that I had. And if something's not working for you, please do provide another way forward for all of us. Okay. Yeah, that's not working. Why? Yeah, I don't know why the Zoom is being so weird. Oh, did it just no? I don't know. I'm gonna stop sharing for just a second and see if I can get it to start. So just need to do what it's supposed to do. It's still just showing you. Yes, that's ask her to come back. All right, let's see here. With this, okay. And then if I go into. Yeah, okay, so that's gonna work. So now I need the Zoom to come back up. So there's the speed. Yeah, that's hard. So too. That's. Okay, now it's showing. Now let's see if I can get it to make this. Okay, working again. Okay, we're gonna keep going. Okay. I always hate when people get up and talk and I'm like, ooh, who is that person? And then I'm Googling them to try to figure out more about them. So I'm just gonna share a little bit about myself. I am a person in addition to being a scientist. That's part of me. I do have a family. That's my 2 kids. I've now been on the other side of things where my kid has been going to look at colleges and universities and I get to see it from the other side. So he's headed off to college in the fall. My younger is 12. I grew up in Central Mass on a lake, which is probably why I said lake, so as you will see. I went to the University of Rochester, so liberal arts is really near and dear to my heart, and that's part of why I ended up where I am in my career. And then I got my master's and PhD in lake ecology at Michigan State University. I went off to my first faculty position at what used to be called Purdue North Central, it's now Purdue Northwest. And I chose to go there because I loved teaching and I loved students. And so again, that sort of liberal arts kind of background is very important to me. But I actually also realized quickly that I missed having folks around to collaborate with, to do research with. And so I actually went back to MSU a short time later, a couple years later, and got my second faculty position in something called the Lyman Briggs College. And so probably you've never heard of that. It is a basically a small liberal arts within the R1. And so we are a college of about 2,000 undergraduate students, a very interdisciplinary STEM college. We don't do graduate students. All the faculty who are there center the student experience. And so it was a perfect place for me because I could really focus on students and have a research program with colleagues all across the R1. I was trained as a traditional limnologist or lake ecologist, which means that I went out in boats to sample lakes. And then as I progressed in my career, I kept getting more and more interested in thinking about lakes as populations. And so I like to think about being a lake epidemiologist, right? So doctors study individual lakes, as do often limnologists. I really wanted to understand why some lakes react differently to things like climate change and why others do not. And so I started to get really interested in that. And so over time at MSU, I built a research program with my longtime work partner, Pat Serrano. If you've read the paper about strong ties, that is what we are. We've worked together collaboratively for over 20 years, and we do more together than we could ever do, each of us on our own. So much of what I will be sharing with you today is also thanks to the work that Pat has done. So our idea back in the noughts was to understand and predict lake water quality at the population level. And there weren't very many people thinking about lakes at the population level. So we were excited to embark down this road, but we very quickly realized that we couldn't just jump into the science. And that's because first we had to build some theory. And so as it mentioned in my introduction, Pat and I and a couple others that you'll see a picture of later, we first took principles from landscape ecology and merged them with limnology to form the field called landscape limnology, really thinking about lakes as patches on the landscape. And then along came macrosystems biology, the program that NSF launched in 2010. And we were right there at the beginning, trying to figure out, okay, so now let's take the principles that we had really developed and the tools we developed doing landscape limnology and include all the rest, do all the ecologies. And so that paper that you all read, right, that's Heffernan et al. If you look at the acknowledgements and the author contribution statement, that's actually Heffernan and Serrano et al. Because Pat and they actually co-led authored that paper. So we also realized, in addition to building theory, that we had to build the research infrastructure to be able to study lakes at scale. And so by research infrastructure, I mean lots of different things and lots of aspects that are equally as important. First, we had to build the data and the tools to be able to study lakes this way. And so there's thousands of lakes across the US. There are hundreds of drivers that affect lakes, right? So in the picture here, it's just things like climate and land use or land cover. And then the other picture I show there is surface water connectivity. But you can think about all the things that affect lakes across the, both in the atmosphere and on the ground and underground. And so we needed to build a framework to be able to capture all that information. You can't just study lakes as isolated systems. So what that meant was we spent I wish I was joking, but we spent 20 years building Lagos US. And so Lagos US is a open access, research ready data platform for everybody. And so it is for the 500,000 lakes that are across the entire US. All lakes 1 hectare or greater in size are included in Lagos US. And it has all sorts of other atmospheric, climatic, land cover, all the variables that are associated with lakes. And those are characterized at multiple spatial extents, and they're characterized through time. And so Lagos is available for everyone to use. Neon is amazing. I use it all the time. But if you're an aquatic scientist, it falls short. There isn't a lot in neon. There are very few lakes involved in that are neon sites. And so Lagos, we developed that to help supplement. I mean, our vision was before neon even happened, of course, but we view it as really supplementing neon's amazing terrestrial data. So this platform that we've created, it really was facilitated by the principles of open science and by the movement of open science. When we first started in 2005, it wasn't a thing, and we were really pushing uphill. And as that all happened, as open science really took over, it became so much easier to do our work. And so we've really tried very hard to then stay up with that and to continue those principles so that everybody else will be able to use and reproduce and extend our work. So what that means is that not only does Lagos have data that are open access, they are extremely well documented. One of the things the speaker last night talked about was how wonderful Neon is because everything is done the same way and all the documentation goes to all sites. Well, we used existing data. Guess what? Not all done the same way, not using the same methods, not documented the same way. So it meant we spent years authoring metadata and pulling together all these data sites so they would talk to each other. And so then we authored those as user guides for our modules as well. And then wherever appropriate, we publish a data paper so that then the people who did all that work to create that data can also get cited as those data are being used by others. And so that is facilitated by all of our data are up on Environmental Data Initiative, EDI. That's a picture of Brenna, who was the past director of that. We also have some ancillary things that are on Zenodo, Figshare, or our Git. And then our data papers are published, a lot of them are in Limnology and Oceanography Letters, which has a data paper format. Some of them are also put up on bioarchive as soon as they're ready, and then scientific data. And so this is what an overview of what that ended up looking like. When we started in 2005, I can tell you it was not with a vision of this, right? But it came together this way. So we have Locus, which is the core central module for the Lagos US research platform. It carries all the identifying information, all the locational information. And then the other two core modules are Geo and Limno. So Limno has all the in situ lake data, Geo has all the landscape and climatic data. And then currently there are 5 extension modules. And anybody can build an extension module and add to it. The idea was we made this platform so it would be extensible and other people would be able to add on. So one about reservoirs, because guess what? There are tons of reservoirs in the US and there wasn't previously a way to classify all lakes across the US as a lake or a reservoir. We compiled all of the existing lake depth that was out there that we could find into one module because lake depth is extremely important for lots of processes that happen and for biota. We have a human module that includes data from the human census and the surveys that go along with that throughout the years so that we can study environmental justice issues. We have a networks module that looks at just the chains of lakes across the US and does all sorts of network metrics if you're interested in networks. And then we have a Landsat module, and that's using satellite remote sensing and ground truth data to predict many in-lake characteristics for all lakes. Because Limno, which is the core in situ data, right, that's just for a subset of those 500,000 lakes. And if you're interested, if you study lakes, just FYI, we're working on a new release of Limno that'll include more recent years and more data. Okay, so that's the data and tools that people usually think about when they think about research infrastructure. Well, we realized early on that we also had to build research infrastructure in terms of teams. It is just as important to have highly collaborative, highly functional teams working on science as it is to have data and tools that work. Because if the teams aren't working, you're not moving anything with the data and the tools. So we realized early on that there were a lot of synergies that existed at the intersection of open science, team science, and data science, or big data science, depending on how you, or data intensive science, however you want to call it. And we wanted to capitalize on all of those synergies, and it meant we had to really think carefully about how we were working in our teams. So, okay, so our teams over the years, and I'll show you a little bit of information about them, are very interdisciplinary. I'm an aquatic ecologist. You can't build that research infrastructure just as aquatic ecologist. It takes more than that. We wanted to be very inclusive in our teams and to be really thoughtful about what inclusivity really meant and how to embody that. And we wanted to really develop teamwork skills and cultures in our teams so that we were really fostering that then would go out to other teams as people left the team and went on in their careers. So a little bit about our teams, so you get a sense of where I'm coming from. As I said, been doing this for 20 years. So in 2005, our team was relatively small and relatively disciplinary. And what happened is through time, we grew in spatial extent, we grew in spatial resolution, we grew in the number of lakes we included, and we grew in the number of people and the disciplines that were included in our team. And so what that meant is as we were growing through time and changing through time, we had to keep learning about teams and figuring out how to help us work together better. So here's that very first team that started off in 2005, just 4 of us, limnologists, working together with a vision of trying to understand lakes at the population level. And so we were working in just northeastern US, so like Wisconsin, Michigan, Hampshire, Vermont, Maine, New York. I think that was it. And we were in at that time, we could only get data, some of the data for lakes that were as small as 10 hectares. Okay, so you think about what has happened since 2005 in terms of spatial resolution, it's fantastic because now we're at 1 hectare, right? But that's what happens. So then in 2010, NSF came out with their new call for the emerging frontiers of macrosystems biology. And we were all over that. We were like, yes, let's go. We had submitted grants to the sort of more geospatial sort of programs. We had submitted grants to ecosystems. No program really understood what we were trying to do to work at the population scale and understand lakes at the population scale. And so I say that because it is a real issue that, of course, macrosystems has now gone away. All of us doing work that's grown over the last 15 years since the macrosystems program started as an emerging frontiers program. Now, where do we go? Right, so that's something that's a challenge that we all have to overcome together. We have to figure that out. So we were one of the first groups awarded and started our team in 2011. And we said, okay, we're going to take that, what we learned from starting with 6 states, and we're going to scale it up. We're going to do the whole northeastern US, 17 states, 50,000 lakes. Now we can go down to 4 hectares as a minimum. That meant we pulled in GIS experts, database experts, ecoinformatics folks, and data scientists. And when I say data scientists, I mean both statisticians and computer scientists. So we built Lagos Northeast. We were so glutton for punishment. Looking back on it, I do not know what we were thinking. But in 2016, we started a new project called Continental Limnology, where we decided, oh, we've got the part of the United States with the most lakes already taken care of. We need to do all of conterminous US. I'm here to tell you that took us 10 years. Building research infrastructure is hard. It takes a lot of people and a lot of time. But we now have Lagos US, all 500,000 lakes across the US that are greater than 1 hectare. And we had to do that, the way we did that was by adding more computer scientists, more statisticians. So that's the teams that we've been working with, and the lessons that we've learned come from those teams, and that I'm sharing with you today. So when we first started in 2005, and then as we moved up to that first group, we called CSI Limnology. That stands for Cross-Scale Interactions, by the way, which is part of that Heffernan paper. But we also joked a lot about doing autopsies in lakes and that kind of thing. But when we first started, so I would say sometime around the late noughts, we really were naive too. We thought we're gonna build a diverse team of experts, and voila, we're gonna come out with all sorts of amazing science. And over time, we recognize that there's a lot of things that teams need to be successful, right? If you read that love paper, trust was like brought up so many times in there. Trust, fairness, clarity, transparency, freedom, understanding. And there's a lot of challenges when you work together as a team. If I said to you, think about the team you've been on that was the most dreadful, you all would have a picture in your head right away, right? We've all been on teams that all they like, you're just not functional. So there's power differentials, there's unwritten rules, there's lots of constraints depending on rank or career stage or where your job is, or what all sorts of perceived constraints. There's conflicts. Conflict negotiation is not something most scientists are particularly good at. There's skills deficits, right? If you're in a team, you might have a computer scientist who's amazing at, machine learning, but you need to be able to talk amongst each other and share those skills, and other people on the team may not have them. And there's disciplinary gaps. As an example of disciplinary gaps, I'll just share, we used to have also a summer meeting every summer. One summer meeting, no lie, we spent an hour talking about the meaning of the word extrapolation. Because guess what? Ecologists, statisticians, and computer scientists have different definitions of that same word, and it was tripping us up all over the place. We had to come up with a common definition for our team. So there's these disciplinary things that happen in teams. And just a very quick segue, because you are all at PUIs, I want to just share that part of how Pat and I moved forward with teams was because of the teaching that I was doing. You always hear about how research informs your teaching and how you bring your research into your classrooms. What we did with our teams was because of what I was learning as a teacher. In my intro bio labs, which are inquiry-based, they do experiments, my student teams were having so many problems. They were completely dysfunctional. I spent the first 4 years of my faculty career at MSU learning all I could about how to help students work together on teams. All I could. I read everything from business, organizational psychology, education. And then we started working in this team for macro systems, and it was the same stuff. And I was like, oh, all that stuff I learned for teaching, I can use it in my research. So I share that because I think it's really important for people to recognize it's a two-way street between teaching and research. It's not just one way. Okay, so we use the science of team science to build and foster our research teams. The science of team science is a thing, it's a field. So if you haven't actually checked out the society, the professional society, that's the site's Science for Team Science. Their website is at the end of my talk. It's a helpful one. They have lots of resources. It developed around the same time as macro systems. People had been doing research on teams before. It has a long history in many disparate fields. The science of team science came together and pulled that together. It was about studying science teams. So the paper you read that I published in 2014, that was the first special issue about macrosystems ecology that we published in FEE. There's been, of course, 2 special issues since then. And so I'm just going to give you some highlights from that in case you didn't have time to read it, or maybe you read it like a month ago. So the idea being that It's not just pull together a team and they're gonna do amazing things, but there's a lot that goes on in between. So there are things you need to be thinking about. You need to be thinking about team diversity, interpersonal skills, team functioning and communication. All of that feeds into the research outcomes that you're so focused on, right? Your project time that you're spending here to develop your projects, to work, to do the analysis, all of that is facilitated by anything you do to help improve your interpersonal skills, your communication skills, your team functioning skills, your teamwork skills. Okay, so I'm gonna talk just a little bit about each of those. So we start first about diversity. When I say team diversity, it can mean lots of things, right? So in this flashpoint world we live in, no one's supposed to use the word diversity. Gosh darn it, it's difference. And it's difference in all the dimensions, right? So yes, there's demographics, but it's points of view, it's career stage, it's degree of incumbency. So what they've actually done research that shows that the best functioning teams have teams that are about 60% people who've worked together before, and somewhere between 30 and 40% new people, right? So like there's stuff out there that you can learn that then will help you when you're pulling together a team. There's interaction modes. So some people are generalists, some people are specialists, and some people are brokers who can help people in different fields, for example, communicate with each other. It's really good to have people who have different interaction modes on your team. And then it's a disciplinary balance. Our first team, the middle one, the CSI Limnology team, we only had one computer scientist on the team. Guess what happened? The poor dude, right? Like we were going to him all the time. He had no one else to confer with, and he had to do all the explaining and educating of all the stupid ecologists, right? What were we thinking? So then when we built Cont Lindo, we were like, okay, we're keeping a certain number of those folks. We need to add some new people and we need to make sure we're adding more computer scientists, right? So having that balance is really important. When I talk about interpersonal skills, these are things that are learned and practiced. We as a society like to think that we're all born with an ability to do things and it's innate. That is not the case. Just like you learned your science, you can learn to improve your social sensitivity and your emotional engagement. You can learn and you can practice. You can do this individually and you can do it as part of your team. So these are things like empathy, honesty, clarity, integrity, accountability. And then the engagement piece, it's excitement about the research, it's commitment to the team, it's trust. These are things you actually have to work on. They are not something that you were born with that you're just gonna, it's just gonna show up. So the middle box, the team communication and team functioning, again, skills that you have to learn and practice. So these are things like idea generation. So if you're at a table with 8 people, what are the strategies you use to ideate? Again, that's not something you're trained in your ecology lab to do. You actually have to read about it, practice it, practice it, practice it, right? What are the best ways to communicate, right? It's about listening, it's about body language, it's about speaking, it's about tone, it's about all the things. So again, it's things you need to really be cognizant of and learn and practice. Decision making is really different when it's not just making a decision for yourself, but instead you're making a decision as a team. And then time management, that's something everybody thinks about as being individual. There's also time management when you're part of a team, right? You have to wait for somebody else to finish an analysis before you can do something else. That's team time management. So you have to pay attention to that. And then conflict management, I put that last because it's like a dirty word, right? Conflict, people hate conflict. As scientists, we are trained to avoid conflict, but conflict is actually really necessary. There's something called the sequential stage of a development that's about the way that a team forms and works together. And it shows that the research around that shows that you will actually do better as a team after you've worked through some conflict together. Like, it's good to actually have to work things out. Think about it in your personal situations, right? Your best friends are people you've lived through some tough times with. It's the same thing as a team. So we need, as scientists, to actually get training on conflict negotiation, right? So these are all things, if you look at the appendix that's online for that 2014 paper, there are some activities in there that you can use in your teams to help you with some of these. I have lots of example activities that I've used with CSI Limnology and Kotlin that I'm happy to share. You can always email me. But we're gonna do a quick activity that's gonna help build some awareness about yourself and about then later you within your teammates. So everybody needs to open their computers, those who are here in the room. We're going to do a very quick questionnaire. It's only 5 questions, so it's very fast. So for those who are online, we're gonna put a link in the chat. And so there is a link to the questionnaire. For those of you in person, if you go to the workshop folder, and then inside that workshop folder, there's a folder that says Team Science Resources. And then inside Team Science Resources, there's an activities folder. And so the first thing you're going to do is you're going to open up, there's a working styles assessment. I'm going to give everybody a moment to find that. You know, your computers were all sleeping, you probably have to connect to the internet again. If it's like my computer, it takes a while to do that. Yep, and then activities. And then it's the PDF, you're gonna open you're gonna need both of the part ones, but the PDF is the actual assessment. Again, 5 questions, and then you're gonna record your answers to those questions in the sheet, the Google Sheet, that also says part 1.
Could you remind us where we're going for those of us who?
Yes, totally. Team research, so if you're in the workshop are you in the folder for the workshop?
Yeah.
Are you sure?
Yeah, I
Okay.
downloaded everything to my computer
Oh, but when?
this morning.
Okay, probably that's okay. So then if you go to the team science resources folder and then activities. Yes, and so you're going to be the assessment, part 1, working styles assessment is a PDF, and then you're gonna record your answers inside the Google Sheet. Is everybody online? If anybody is having problems online, are you just let us know. Is everybody able to type into the Google Sheet?
It throws you out from the Wi-Fi.
Activities.
Yeah.
And then
Yeah.
Okay, you're able to write.
The Excel and the PDF.
You're so happy, I'm sorry. You're able to type into the sheet.
So we're putting easy.
Yes.
So this. Into this.
Right, so question 1, answer A, B, C, D, question 2, that's better. Well, at this, next stage.
So just.
And A equals 1, that's for the scoring. Yes, everybody online doing okay? Yes, I should. Thank you.
So this is the question.
Oh. I know.
I see where it is.
It's not getting hard. That's.
I know, it's only 5 questions. Feel free to color code your well if you need some language.
Which one's these? Oh, yeah.
The doctors,
The doctor, they're very proud.
Okay, it looks like everybody's in there, so that's good.
Off the board, man. Wonder what this means about me.
So so the, one, just put it in there, I can believe that part. Just put your ABC again, I'll do the rest. As long as you get the A, B, C, or D into each of the 5 question columns for each of the. Each question, I can do the rest at lunch. We'll be coming back to this in the workshop. So really what's most important is that I know your answers to questions 1 through 5. So that then if you're confused about calculating the most preferred, I can do that at lunch.
Sorry, it's a question, it was really pounds for the old school.
Oh.
Well, is
That's interesting. I've never had a 0 type of loop before. Ah. Okay, I'm gonna give everybody 1 more minute and then we're gonna move on. I'm gonna use these scores at lunch to make some graphs and do some calculating, and then I'll come back to you during the workshop with them. So don't worry, I'm only leaving you hanging for like an hour and a half. By yourself. Oh, yeah.
Implied that these are all.
Okay, hopefully you were able to get those 5 questions answered. Which ones have been? The top that we need to know these. All right. I will come back and give you information after lunch, I promise. Okay? So as I was saying, taking the time to learn about yourself and to then be reflective and then share with your teammates is very important. That's just one of many ways you can start that process. Okay, so Pat and I, we went all in on this idea that we really needed to build the environment and culture that was needed for strong collaborations. And one of the ways that we did that, in addition to doing activities and icebreakers and socials and all the other things, was to draft and implement a bunch of team policies. So I'm just going to share with you a little bit about team policies. So what is a collaboratively drafted policy? And some people, their eyes start to glaze over, like, who cares about policy, especially when you're talking about academic policy. Oh my goodness, bylaws? No, don't worry, we're not talking about that. A policy is any kind of deliberate system of principles that guide your decisions and to help you achieve outcomes, right? It's making the implicit explicit. It's a statement of intent. It's the way that you decide as a team you want to work together, right? You can do a policy about all sorts of things, things that are managerial, financial, administrative, scientific, all sorts of stuff. And these policies are called lots of different things. So they are called norms, which 10 years ago, I didn't even know what the word norm meant. That was like a humanities thing. It's like, what is that? What are they talking about when they talk about norms? Now it's much more mainstream to talk to develop meeting norms, right? You can call them best practices. You can call them SOPs. You can call them guidelines or MOUs. But the idea is with all of these is you're making things explicit and you're writing them down and then you're keeping yourself and everyone accountable to them. So what kinds of policies, what types of things might you want to think about having a policy for in your team? It's really anything that follows unwritten rules or expectations. So, right, when we came into this room and you sat down and I was gonna start the talk, I started with some talk norms. Everybody, when they walk into a talk, in their head, they're like, I know what's expected of me in a talk. Do you think the person next to you has the same ideas about what's expected of them as what you expect? No. So those are all assumptions that we make. And so you have to actually have the conversations and make it all explicit, which means writing it down. Anything that involves a power differential, this is super important to have a policy about. Anything that makes you uncomfortable to talk about, that's an indication that there's a power differential and that there are unwritten rules and that you actually should have a policy about it. Okay, so that's a good rule of thumb. So here's a whole bunch of things that we develop policies for. I'm not saying y'all as MEFA teams need all these different guidelines or norms, but you might need some of them. So things about attendance or participation, things about workload, communication, meeting norms. When you're working together distributed across institutions and you're doing a Zoom meeting, what do you think other people assume about your level of engagement? Do they assume you're going to turn your camera on? They assume that if you're muted, it means there's noise in the background? Or if your camera's off, maybe it means you're not there or you're not engaged? What do you think they think? Well, let's talk about it. Let's talk about how we want to engage with each other in these virtual spaces. Then we had policies about how we were going to allocate resources and funds, expectations for those who did receive funds, right? So awkward when you think that someone who's being paid is going to X, Y, or Z. So some people, when they're getting paid, they think that means they won't be a co-author because they're getting paid. That's their job. Other people think, wait, I'm getting paid, but I'm doing all this work on a paper, I should be a co-author. So authorship policies are extremely important, right? There's all sorts of things that come up with authorship. There's also lots of stuff that comes up about data and code sharing. You have a Git, you think everybody's on board? Have you had that conversation? Is everybody on board? Can't tell you how many meetings I've been to where I think everybody is all in on open science, and guess what? They're not. Team members who helped write the proposal. You gotta have the conversations and come to agreement. So as a real quick example, we have authorship is very fraught. So I'm going to share just a little bit about our authorship policy. Some of you are just starting your projects together. You haven't even thought about authorship yet. And so it sounds like you use a system, Erin, maybe you use some other system. This can help you be thinking about how you want to work together as a collaborative manuscript team. So an authorship policy is a document that describes the team's procedures and guidelines related to development. Having an authorship policy, basically it opens up the conversations. It's really important to have those conversations. And to talk about what does it mean to be an author? What does it take to be an author? How do we want to order authors? What does it mean if you're all in and then something happens because life happens and you have to step back? How do you extract yourself from an authorship team? all those sorts of things are important to be talking about, and that can be part of an authorship policy. We always, we have a template that you can use, on Figshare, and I put it in the resources, folder for you if you wanna look at it. And it gives you all the steps and it gives you something to start with. So I'm not gonna talk through each of these things, but it gives you an idea of what's there right in the template. I will say though that if you develop an authorship policy, so like your lab at your institution, if you have a bunch of undergraduates working in your lab and everybody's working on one project together, and there's gonna be a paper at the end, right? Really what works best is for everybody to be involved in the conversations and for any manuscript that to be revisited, okay? Because it really works best if all manuscripts are follow the policy and everybody's involved. So that means you have to revisit every time your team changes. I know it's a pain, but it really helps. It reduces the amount of conflict after the fact drastically. We also realized that sometimes people have individual preferences about how they like to lead manuscripts, right? And so it's also really important to have a conversation about that. And so we wrote a paper about how lead authors work in collaborative manuscripts. And how that then can how that affects your team. And so this is a different paper that I also put in that folder for you. That really can help you sort of think through and learn about yourself. Like, how do I like to lead a paper if I'm the lead author? One of the things our team does a lot and has for years is we do a lot of co-led papers. And sometimes that's two people who are co-leads, and we always are very clear about that when we submit the paper. And then on CVs, we've worked with everybody to show how to designate that. And we write an author contribution paragraph for every single paper that includes that information. Sometimes it can be more than two. The idea being that how you lead a paper, it could be that there's 4 of you on a MEFA team and you all equally contribute. Why is it that one person then is lead? You can write an author contribution paragraph and specify that. And so what we did was we wrote this paper. It was actually a very fun paper to read. There were 4 early career scientists who co-led the paper. And we came up with some funny sort of catchphrases about the different ways that people tend to lead papers, or the ways that they've had to lead papers, depending on the situation. And it's on the x-axis, you have the number of lead authors, and then on the y, it's sort of this degree of interdependency. And came up with these funny names, organized chaos, power of directors, dynamic duo, right? The lone wolf, that's the most traditional. But in the field of macro systems, right, the lone wolf isn't happening quite as much. We have lots of co-led off papers, right? Maybe it's an ecologist and a statistician who work really closely together, for example. And what we found was that in our Lagos team, we had worked together to come up with some guiding principles that were important for us for our team. And so after lunch, this is one of the things the Love article also talked about, was coming up with team values. You could also call these guiding principles values. We came up with these guiding principles for our work together: efficiency and productivity, transparency, accountability, creativity, inclusion and fairness, protection and promotion. I have them on a balance there because you can imagine you can't actually maximize all of these at once. And really the type of paper, the way that you lead a paper affects which of these priorities is going to be maximized. And so that's a challenge that we often would run into when we were working together in teams. So here's just an example. If you think about the lone wolf, that principle that you're really maximizing there is efficiency, right? That one lead author, they're gonna just be able to go at their own pace. On the flip side, the round table, where everybody is included in all major decisions, not efficient. Think about how long it takes us just to make a meeting, just to find a time for 6 people to meet together, right? So efficiency is not going to be prioritized, but inclusion is, right? So thinking through, like, what does it mean if you as a team come up with a value of inclusion? Then how do you actually embody that when you're working together on a manuscript, right? It's not about, you can still have that principle, but maybe you can't maximize it in every situation. So again, it's about having those conversations and being really, really explicit when you talk about authorship. Okay. So that's my like kind of overview of why you should care about teams. And I will say that over the years, the last 20 years, I've given a lot of talks like this. And I've been told by a lot of people, like, yeah, I agree. I actually at one Macrosystems PI meeting, I had a very, very senior, very well-known person, I will not name, come up to me afterwards and say to me, that was an amazing talk about teams. I agree with you. And I'm also not gonna do any of that with my team. It takes time. So you actually have to commit to prioritizing it about the same level as some of the other things that your team does together. It's hard. Okay, but if you prioritize it, if you include developing team skills and cultures as one of your goals, you can have lots of many good outcomes. Okay, first thing is you have many important conversations, things like we would talk about what is good science, right? Experiments versus data mining versus simulations versus process-based models, right? Like all the things that are out there that we have these sort of associations with, right? We have conversations about power dynamics, about working styles, which we'll talk about later, about conflict negotiation, giving our early career folks on a team training in conflict was so good. I mean, I still hear from people now coming back saying, wow, that was really helpful. I had this thing in my lab, recently, or at my job. And then project, paper, and personnel management. These are all things that are really important to talk about and to learn and to practice. As a result, our Lagos team was highly productive. We had many research articles come out. We didn't spend all of our time doing team science. We actually did, or working on our teams. We actually did produce a lot of science. And many of those papers that we produced were multidisciplinary. And our average number of authors was 8. So we did figure out, now this is not to say we didn't ever have problems, because we still did, everybody does. But we got a lot done. So as an example, just to show you that I'm not just talking out of my, this here on the left, these are papers, articles that have been published using Lagos Northeast or US over the years. Blue is our team, the papers that we have published, and then the orange is other people. The idea when we built Lagos US was that we were building a research-ready platform for others. We wanted to see that orange line go up over time, and it is. And you'll see on the bottom, there's the X's that shows where there's been different releases of data as the modules came out, and we just keep increasing. And so my first thing is to say to all of you, go download Lagos, let us know if you have any issues. We would love for you to be able to use it too. This is our, we created a Lagos Google Scholar page. Again, it's being used, it's being cited. Because we have data papers, we can also get citations that way. We can show NSF, we can show Congress. This is what that money that you allocated to us went for, right? We have to be able to talk about the impacts, not just to each other, but to others. And we had lots of amazing science outcomes. This is just a graphic that we created for our NSF final outcomes report, right? So it highlights just a few of them. But some of the things that we're most excited about by being able to scale up the entire US and look at lakes at the population level, we were able to understand things about lakes, about climate's effects on lakes, about nutrients within lakes, about environmental justice that we never would have been able to understand if we had kept studying lakes individually, one at a time. And so we learned a lot from creating Lagos, both in terms of the research infrastructure, how much it takes, how long it takes. I never want to author any more metadata again in my life. Like I feel like I've hit a certain age where I'm like, I'm done with metadata. That's not true. I'll just always be in metadata, I think. But like, there's so much that can be learned by anyone, anywhere, using Lagos, and we hope that others will use it. Okay, so what are next steps for your MEFA teams, right? Seek training, do some reading, learn about practices for true inclusion, learn about conflict resolution, learn about communication skills, learn about maximizing creativity. This morning, there was the comment that like in some of your collaboration plans, people are talking about consensus. It is the case that scientific disagreement is actually a good thing, right? And so we need to be thinking about, yes, we're gonna go with the majority, but what happens, how do we acknowledge and appreciate the dissenting views? And then when we're in a situation where there is a dissenting view, how do we want to really be together as a team, right? It's not just about, okay, we're just going to use majority rules. It's about what are we going to do next? And so I thought what you were saying this morning made a ton of sense, right? Making sure you're thinking through, how are we going to make sure that folks who don't agree continue to disagree in our teams? Because we need that disagreement to keep being creative and to be the best scientists we can be. And then I'm just gonna say that developing policies, best practices, norms, whatever you wanna call them, it's really good for the team. You can copy what's out there, what works. We've got examples that we'll share. You want to revisit and revise them often. And you need to keep yourself and your team accountable. Even in our team, every once in a while, somebody will be like, hey, remember that authorship policy we have? I feel like we're straying a little bit. And I'm like, oh yeah, you're right. We need to be realigned, right? It happens. So we have all sorts of policies that we're happy to share. I have to say, we just launched our new website, the Bridge Lab website. And when I was making this, I realized I'm not exactly positive where those policies reside at the moment. So if you go to the Lagos website or the Bridge Lab website, and you don't see, just email me and I'll send them your pay and figure that out since this new lab website is up there. We've also published a bunch of papers over the years about how to work together as a team. Those are all included in your folder there, I don't know what I need it, but there's a folder in there with resources. And I also just want to highlight a few other things that I think are really helpful. The National Academy of Sciences, Engineering, Medicine has a team science guide. The NIH has a team science field. It's called a Team Science Collaboration Field Guide. Has awesome resources in there. And if you're in a team that's really interdisciplinary, the Toolbox initiative is really good. And so that's a place that you would want to go if you're dealing with disciplinary differences. And then the Science of Team Science, that's that professional society that I told you about, that you might want to look at their website. And then these are just brand, newer ones. So the NASEM actually put out a brand new report just like a month ago. It's in your resources folder for you to check out. This is that love article that you read for today that I referenced a couple times, and we'll talk more about it. And then I added to your folder a book chapter, because often when you do a search, if you're searching for stuff, book chapters don't come up. So I put this paper by Read It All in there. That's teams, networks, and networks of networks, and it's kind of an interesting read as well. So I put that in there because often people don't find it. Okay, so lots of resources. Obviously, with all our computer issues and our late start to begin with, we're a little going into lunch. So it's up to you if you want to do some questions now, or if people just want to come up to me afterwards or whatever. That's totally up to you. And you can always reach out to me. And we're gonna have time together after lunch, doing some more work together, so.
Yeah, I'll just speak to the owls so that the online people can hear me as well. I think let's hold the questions until after our workshop, because then we'll just have a little more flexibility at that point. And yeah, we'll go to lunch. We'll reconvene at 1:15 to follow up with more conversation with Kendra. And let's thank her very much at this point.